Hello again, and welcome to Ramp and Roll. Hi, I'm Dave from Physics and Astronomy at Purdue. Ramp and Roll is a companion activity to Newton's cart. Some of the materials that you will receive for Newton's cart will also be used ramp and roll, and vice versa. Ramp and roll and Newton's cart are companion activities. Some of the materials you will receive or that you will need will be packaged with one activity or the other, but they'll be used in both. For example, you will need some marbles of various sizes and masses. So these are going to be packaged with ramp and roll. You'll use them in both activities. There are 4 or 5 size marbles to give your students opportunity for plenty of variety. These are corner guard. We got them at one of the local hardware stores. They're corner guard with a curved inner surface. These work well and they balance fairly well on various kinds of cups. So for example, the styrofoam cup, a solo cup. Now that might be a little high for the activity. Cut it down. So that would be a little more appropriate. I think we suggest heights of 2, 4, and maybe 8 centimeters. That's certainly up to your discretion. You could use 1, 2, and 3. That's entirely up to you. You will also receive a stopwatch, again, used in both activities. I think that pretty well describes what will come in the kit. The whole object will be to use ramps of various lengths and altitudes to roll and time marbles. The video for how to do this experiment is being produced by my colleague, Zeynep Akdemir. Zeynep is in Turkey for the summer, so her materials may look a little bit different from what we have here, but the idea will be the same. So with that, I will turn you over to Zeynep and let her show you how to do the experiment.
Hello again. In this lesson plan, with the ramp and roll track system, we will teach our students how to learn the concept of gravitational potential energy, the law of conservation of energies, kinetic energy, and how the transformation from potential energy to kinetic energy occurs when there are different marbles in the system. This is the first track that I will be using with the 2 centimeter high inclined ramp. This is the second system I will be using with 5 centimeter high inclined ramp. And this is the third system track that I will be using with 8 centimeter high inclined ramp. In this experiment, we are using the same mass variable with different inclined ramps with different heights. So the essence of the first experiment to see how far the marble travels in the ramp and roll system and how much time does it require to reach to the stopping point. We will record the distance and the time, and we will ask students to calculate the velocity based on the data they have in their tables. So here it's important to remind them that we are releasing the marble from the top of the ramp without any force acting on it. We are leaving it and calculating the time and then the distance. We want students to place the data they have into the data table at the 9th bullet point of their worksheet for the experiment A. So for the first experiment, I made a rough calculation and placed the data I have for the first experiment I showed you in the video. I'll do the same with 5 centimeter high and 8 centimeter high inclined ramp. Release the same marble from the top of the ramp, and then we'll see how the distances traveled, time spent, and the velocity changes according to the height we kind of used for the inclined ramp. I will be repeating the same experiment with 5 centimeter high inclined ramp this time. So I have the same marble with the same mass, and I'm releasing it from the top of the inclined ramp. And we'll see how far it goes and how much time it spends during the travel. As you can see, since we have a carpet on the floor, because of friction, it had to stop. But in your case, you may use a hard floor and you can just let the marble go away and measure the distance accordingly. As the final step of the experiment A, I'm releasing the same marble from 8 centimeter high inclined ramp. Here it goes. Once you ask students do the experiment with different heights, let them record the data accordingly. So here there are different roles with the heights. So ask them to do the trials first, second, and third, and record the distance and time accordingly. In the part 2, ask them to graph the distance-time relation when the Mar travels and the Ram staying on the ground. Please make sure that they understand the idea of the average velocity by dividing distance and time. But the idea behind this is when the distance increase, the time also increase, so the velocity stays same, which makes it the average velocity in the system until the marble stops. So this calculation will start when the marble reaches the bottom point of the inclined ramp. To calculate the average velocity, you can use 5 centimeter high ramp for the experimentation. Start recording the time and measure the distance when the marble reaches the bottom point. I actually recorded distance and time for you as an example, so it is enough to do one trial for this part. I recorded that the distance was 1.02 meter and the time was 1.03. When I divide those two values, I found the velocity as 0.990 meter per second. So this is the velocity for the height 0.05. Please let students know that in the second part, in the experiment B, we will look at the law of energy conservation by checking this formula. So the first initial energy of the system should be the gravitational potential energy of the marble that is about to release from the inclined ramp. And it has no kinetic energy in the beginning. And when it reaches the bottom point of the inclined ramp, it starts to move until it stops. So it doesn't have gravitational potential energy because it converted to kinetic energy at that point. And the distance and the time we calculated for the 5 centimeter high ramp gives us the average velocity, which will lead us to the formula of the kinetic energy in this part. We need to calculate the initial energy in the Rampant roll system. So the initial energy should be the gravitational potential energy of the marble that is about to release. Mass is in kilograms, which was measured by the scale. Gravity is constant, so it's 9.81 meter per second square, and the height we used was 5 centimeter inclined ramp at this time. So it also was converted to meters, which is 0.05 meters. So when we multiply all of those values, we obtain 0.000371 kilogram meter per second square. In the experiment, as you remember from the data table, we calculated the average velocity of the marble traveling on the ramp, staying on the ground, was distant 1.02 meter away in 1.03 seconds. When we divide those values, we obtain that the average velocity was not 0.990. So when we include all other values, the mass and the velocity average, into the formula of the kinetic energy, which was calculated by average velocity, we obtain that the value of the kinetic energy was 0.00371 with integers, slightly different integers from the gravitational potential energy. These results tell us that the potential energy, the gravitational potential energy, and the kinetic energy are perfectly conserved in our experiment. Thank you for watching and listening the video. I hope it helps with the experimentation process you will have with your students. Please give more emphasis on the concepts of the gravitational potential energy, which variables affect the energies, and also the making sense questions we place at the end of the student worksheet. Thank you.